Hey Math Stars, welcome to your first AP Calculus AB content video shot from my home while I'm socially distancing myself from the coronavirus. And I'm wearing camouflage today, so hopefully you're able to still see me. Okay, so today we're just going to do a real quick lesson on area between curves, and then hopefully you'll go into AP Classroom and take an area quiz. It's not a quiz, it's just like I thought it'd be easier to do a homework assignment that way than having you print out a homework assignment. So let's go ahead and do a few examples. So as you know, an integral gives us area. If we want area between two curves, basically we just need to find two things. Where do those curves intersect? And which function is in the top and which one's beneath? So let's go ahead and start with this first one here. Find the area of the region between the graphs of x squared minus 4 and negative x minus 2. So let's go ahead and make a quick graph. So if I graph x squared minus 4, I hope y'all know that that's the quadratic parent function shifted 4 units down. So plotting some points here, this is what we get. Okay, and then we're going to graph negative x minus 2, which is a linear function with a slope of negative 1 and a y-intercept of negative 2. So here is our picture. Well, pretty easy to tell where the graphs intersect, and it's also pretty easy to tell which function's on the top. So let's go ahead and set up our integral. The lower limit is going to be the first x value where they intersect, which is at negative 2. The upper limit is going to be the bigger x value where they intersect, which is at 1. The top function is the linear function. Now parentheses are your friends. So this time it's h of x minus f of x, because h of x is the function on top, minus the lower limit. All right, Math Stars. So if we couldn't tell from the graph where these intersected, another way we could find the intersection is by setting these equal. So let's just go ahead and practice that real quick. So I'm going to set these two functions equal and solve for their intersections. So setting those equal, this is our friend, the quadratic function. So we're going to get him in standard form. Let's bring the x to the other side. Let's add the 2 to the other side, and then factor it. So you can pause the video, factor it. That would be awesome. Or if you're just going to let it play through, that's okay also. So when we factor and solve, we do get the intersection points at negative 2 and at 1. Okay, but if you can draw a nice graph and get the intersection points from the graph, no need to set them equal and solve. So let's go ahead first and simplify this integrand, and then we'll integrate. So let's just combine like terms. So we have a negative x squared minus x, a minus 2, and then a plus 4, because this negative would distribute back here. Don't forget to distribute it to everything in the last set of parentheses. So we get a plus 2 and then dx. So integrating using the power rule, we get negative x cubed over 3 minus x squared over 2 plus 2x. And then we're going to input our limits. Okay, so inputting the limits, we're going to get negative 1/3 minus 1/2 plus 2. So I know it's been a while, but we're going to first input that upper limit into all of the x's. Super important is to now put parentheses and input that lower limit. So let's input the lower limit. Ooh, lots of negatives. Negative of negative 2 cubed over 3 minus negative 2 squared over 2, and then plus 2 times negative 2. Okay, so let's go ahead and I'm not going to worry about getting common denominators on these fractions. Let's just go ahead and work back here. So 2 cubed is 8, and negative 2 cubed would be negative 8, negative, negative. So the 3 negatives would keep it still a -8/3. This is -2 squared, which is 4, but then negative would be -4/2, which reduces to 2, and then -4. Oops, I forgot to distribute. Let's see. This is negative, but there was that negative in front, so we have to distribute that negative there. And then this is -4, but we have a negative in front, so that becomes a +4. So just make sure, like I forgot, to after you simplify this, make sure you multiply it by that negative in front. So this is a -2 times the negative makes it positive. -4 times the negative makes it +4. Okay, math stars. Here's what's really nice. Even though there's a lot of ugliness with fractions, ooh, wait, that's not true. Fractions are always pretty. Even though we have a lot of work here, apparently with the fractions, if I combine those together, that's just -9/3. So -9/3 is just -3. So that's -3. Let's combine the remaining constants together. So 2 + 2 + 4, that's 8. And then all we have left is that -1/2. So we just get 5 minus 1/2, which is 4.5. So what you want to make sure is that you get a positive value for the area. If you get a negative value, you messed up somewhere. An integral can be negative, but an area is always positive. So when we're finding area between curves, we're always going to get a positive answer. So if you get a negative answer, you possibly put these in the wrong order, or you messed up with your integrating, like I messed up. I almost messed up here with the signs, or you perhaps put these in the wrong order. Okay, this was example 1, but also known as example EP. Example easy peasy. That one was a pretty easy example. Let's go ahead and kick it up a notch. Okay, so we're gonna call this one example GWU, getting warmed up. Okay, so we're gonna find the area beneath the graph. 1/2x from x = 2 to x = 5. Okay, so as you know, the graph of 1/x is in the first and the third quadrants. Looks like this. The graph of 1/2x is going to be the same general shape. It's just going to be a vertical compression, but still the same general shape. And then we're looking at the area from 2 to 5. So this time we don't have a top curve and a bottom curve. We just have one curve. So this integral is just, the area is just going to be the integral from 2 to 5 of 1/2x dx. As this guy's written, he would need some u sub because we don't have a 1/x, we have a 1/2x. But we can factor that 1/2 and bring it in front because that's really the same as just a constant times x there. So let's go ahead and bring that out in front. And then we're just integrating 1/x dx. I know y'all know the antiderivative of 1/x dx. It is ln. 1/2 ln, the absolute value of x, evaluated from 5 to 2. Let's input those limits. 1/2 ln 5 minus ln 2. Wait, there was like some log property that we could use to combine those. So it would, wait, is it product, quotient, or power? Man, I wish I had some math stars here to help me. Quotient. So see that minus sign? We can rewrite that using the quotient property of logs. And so we can rewrite that as ln 5/2. We could bring that 1/2 back and make it a power. We don't have to. We can leave it as the 1/2 in front, but this would be the same thing. And a 1/2 power is also the same as the square root. So there you are. I wanted to show you there's 3 different ways that we could write the answer. Again, our answer should be positive, and ln is positive every time the argument here is greater than 1. So we do get a positive area. Okay, so that was example getting warmed up. We started with example easy peasy, example getting warmed up. I think it's time for our joke of the day. So our joke of the day. What do you call your friends who love math? Your algebros. All right. Okay, last example. I bet you're sad this video is almost over. I'm having a lot of fun. Okay, so our example, yeah, dog. Whoops, not yeah, God. Yeah, dog. So we are going to find area between the graphs of y equals x squared plus 4x and y equals negative x from -2 to 1. Oops, from x equals -2 to x equals 1. Okay, so let's go ahead and get a little picture started. So this guy, if we factor him, so let's factor an x out, x plus 4. So he's got x-intercepts at 0 and where else? -4, good. So he's got x-intercepts at 0 and at -4. Which way does this parabola open? Up, yep. So this parabola opens up. Okay, and y equals negative, y equals negative x. Yeah, so this graph of y equals negative x goes through the origin, and it has a slope of -1. We actually don't need to know where these intersect over here, but we could determine where they intersect over there. The reason we don't need that is because I'm only needing to find the area between the graphs from -2 to +1. But this is called example yeah dog because it's a little trickier. So what's tricky about this problem is to the left of the origin, the linear function is on top. And to the right of the origin, the linear function is now on the bottom. So in order to get the correct value for the area, we need to set up 2 different integrals. So this first integral, what's its lower limit going to be? Well, it's at that first x value where that region starts, which is -2. What's the x value that's the upper limit? 0. So remember, we're going to do top minus bottom. So the top function here, we already talked about that, is the linear function, minus the bottom function, x squared plus 4x. Use parentheses. Then to that, I'm going to add this area. The area from what the lower limit here is 0. We're going from left to right. And the upper limit is 1 because that's where that region stops. Because they said only integrate from -2 to 1. Actually, it's me. I said only integrate from -2 to 1. So we're stopping this one at 1, and we're going to do top function minus bottom function. So x squared plus 4x minus a -x. You can put parentheses around both of these functions that would be fine. But for sure, you have to have them around the second function so you know to distribute that negative sign through. Okay, so I'm not going to finish this problem because it's very similar to the first one we did where we could just combine these like terms, integrate, plug in the limits, and then combine like terms. But I don't think that we need to go through all that work because I believe in you. You're smart enough to figure that out on your own. So, hey, AB students, please go on and do the AP Classroom practice problems and look for another video later this week. I miss y'all and hope you're doing well. Stay safe.